Hey everyone, welcome to today's lesson. Today is going to be pretty much the last part of Intro to Calculus that I'm going to teach you guys. So I want to show you guys this idea called the integral, and it looks very fancy, but it is a very straightforward concept. Okay, so when you see something like this, okay, I'm going to draw an arrow. I want you to read it. I want you to read it as, give me a second, where is my arrow? I want you to read it like that. So you're going to read it as, when you see this funky looking squiggly thing, 1 on bottom, 5 on top, with a 2x dx, the first thing I want you to do, first, for the purposes of just this being introduction, I want you to ignore that dx, okay? And I want you to, let me cut this and paste it here. Okay, so from the x value of 1 to 5, okay, 1 and 5, 1 and 5, they want you to find the area in between the graph of y equals to 2x, this is y equals to 2x, and the x-axis. So long story short, they want you to find this right here, that trapezoid. Okay, they want you to find that trapezoid. Okay, so let me say that one more time. When you see this notation here, it's from x values 1 to 5, the area in between the graph of 2x, which is this line here, this diagonal line. Okay, y equals to 2x is that diagonal line, and the x-axis. The x-axis is not written here, but it's implied. Okay, it's implied. Now, so in this case, you're basically finding the area of a trapezoid. Okay, that's basically what you're doing, which is really easy. Okay, now let me turn your attention to something that looks like, let's say they had this, except they had that same squiggle, but they wrote x squared here. Okay, or negative x squared. Okay, and let's go negative x squared plus 4. Okay, so let's pretend it said negative x squared plus 4. Then you would have some parabola that looks like that. Okay. I'm going to just exaggerate this. Okay, this is not the correct graph for the parabola, but let's just pretend it looked like that. Okay, then you would basically it's asking for this portion here, right there. Okay, asking for that portion. Okay, this is not the correct graph for that equation. I'm just making it up so that it's more simple for you to understand. All I want you to, what I'm trying to basically drive home is that this is asking you for from x values of 1 to 5, okay, what's the area in between whatever this equation is. This could be an equation of a parabola, a line, whatever, and in between that equation and the x-axis. Okay, that's what it's asking. Now in this case, you wouldn't know how to calculate this because this is actually not a trapezoid, because this is curved here. That's curved. Okay, like I said, I just want to drive home that this can be any equation here. And these values could be any values. Right now it's specified in between from x values from 1 to 5, but they could have said x values from 0 to 5. Okay, which brings me to my next point. What if they said, here, instead they put 0 and 5. Okay, 0 and 5. That means instead of a trapezoid, it's asking for the area of a triangle. Okay, it's going to include that portion. Okay, so you would just do 1/2 base times height. Okay, now let's go ahead and figure this out. Okay, so let's figure out this point. Okay, this point is easy. This is 1 comma 0. This is 5 comma 0. And this is going to be 1 comma something. Okay, my parentheses looks like a C. Okay, this is going to be 1 comma something. This is going to be 5 comma something. And how do you find that blank? Okay, well, you just plug it in. 1 comma, let's plug in 1 into 2x. Okay, when you plug in 1 in for x, you get 2 times 1, which is 2. When you plug in here 5 into 2x, you get 2 times 5, which is 10. Okay? So the height here, okay, the height here is going to be 10. Not the height, but this length is going to be 10. This is going to be 2. Okay? And this side to side is going to be 4. Okay? So remember, here is our equation for the area of a trapezoid. This is going to equal to h. H is 4 times b1, b2. Those are interchangeable. I'm going to call b1 10, b2 2, all over. This 2 is a constant. Okay? 10 times 2, 10 plus 2 rather, is 12 divided by 2 is 6 times 4 is 24. And this matches here. Okay? All right. Okay. Now, here's an example. If it's a triangle, it's the same dang thing. You do exactly the same thing. Now, at some point, you're going to do some problems where it's going to tell you, it's going to give you something like this. It's going to be the sine curve. Okay, part of a sine curve. So let's say it looks like that. Okay, because they're going to do absolute value of a sine curve. Okay, a regular sine curve looks like this. Okay, but they're going to make it an absolute value of a sine curve, which means it's only positive. You only get positive y values, which means it's the red graph. Okay. So in this case, this is they're going to tell you, they're going to give it to you in the directions that the area of this is 2, I think, or maybe they said 3, I don't remember, I think it was 2. Okay, and if you have 2 humps, then 2 plus 2 is 4. Okay, that's if they're asking for from that point, that x value to that x value. If they're asking you for this, just this x value from this, let's say this was 0 to 5, x values of 0 to 5, then you say the answer is 2. But if they ask you from 0 to 10, x values of 0 to 10, then you say 2 plus 2, the area, the total area underneath this graph and the x-axis is 4. Okay. Now, by the way, you might be tempted to say, oh, well, this is half a circle and this is a whole circle. Okay. So you take the whole circle, half it. Okay. That's not how it works with sine. Okay. That's not how it works. Sine, one of those humps is not half a circle. Okay. Just look at the graph a little bit more closely on Desmos. Okay. So long story short, I want you guys to go ahead and use, each time you do this, each time you do one of these problems, use Desmos. Put this green highlight into Desmos to see how the graph looks like, and then look at the relevant x values. In this case, the x values of 1 to 5. Okay, so in fact, I want you, for each problem, I want you to, because sometimes they're not going to give you a drawing like this. Most of the times they're not. So I want you to copy that graph, copy this drawing down. Okay, literally that's like 20 seconds max of extra work. Okay, and just, you don't need to label all these points, but make the important labels. You know, like the 2, 4, and 10. That's important. The 1 and the 5 is important. You don't need these red coordinates in this case. Okay, so use Desmos to graph the green highlight. Look at the relevant x values, or you can think of it as x ranges. I shouldn't use the word range because that's associated with y values. Look at the relevant x domains. Okay, in this case it's 1 to 5, and then calculate the area, and that's it. Okay, all right, folks, that wraps up today's lesson. Thank you for tuning in.